Now in this example, I want to show you how to find out the magnitude of magnetic force. A single positively charged particle with a charge of positive 1.6 times 10 to the power of negative 19 coulomb travels at a velocity of 10 meters per second perpendicular to a magnetic field B of strength 4 times 10 to the power of negative 5 Tesla. What is the magnitude of the force the particle will experience from the magnetic field? So in order to find out the magnetic field, I'm going to call it F. F will be equal to B times V times Q times sine theta. That's the relationship between magnetic force in terms of Newton. B is magnitude of magnetic field strength. V is going to be velocity of the particle in terms of meters per second. This one was in Tesla. Q is going to be in terms of charge. That's the charge of the particle. And theta will be the angle between the direction of velocity and direction of magnetic field. Theta, angle between velocity and magnetic field. So let's go back to the question. In order to find out the force, magnetic force, B is given, which is 4 times 10 to the power of negative 5 Tesla. V is velocity of particle, which is given as well in terms of 10 meters per second. So since in 10 meters per second, we don't need to convert it to any other unit. Q is 1.6 times 10 to the power of negative 19. And since they are perpendicular, it means that theta is 90. Sine 90 degrees is 1. So we have maximum force in this case. So let's calculate it. That's going to be 6.4 times 10 to the power of negative 23 Newton. That's the magnitude of magnetic force. How to find out the direction? The direction of this magnetic force, we can use right hand rule in order to find it. But we need to know the direction of magnetic field and we need to know the direction of velocity.